Hello everyone. Thank you for coming to this talk. One of the last ones, probably the last people around here. Um, Congrats, by the way, after 3 days. I know how hard it is. If you don't mind, I'm going to give it in English. If you don't mind. If you mind, I don't care. No, it's for specific reasons. I'm going to give it in English anyway. So I'd like today to give this talk, which is not technology, not about technology. I'm sorry about that. It's pretty aware that I don't give talk specifically on technologies, but it's more like a lecture, let's say. So I produced slides, but it's more for me to not lose my tracks and to not diverge for hours because I could talk about that for hours. So what I would like to highlight today is what is becoming data science. Of course, data science is not new. What is new in data science, let's say? I will try to drive the different claims towards the introduction of functional programming, distributed computing, the JVM, into this new world of data science, and how to make it agile, how to make the overall process agile, right? I'm not talking about methodologies neither, right? Just what is necessary to be at some point in time agile. And for me, agile is just production, right? Productive, not about scrums or whatever meetings you have in mind. So I've created this company, Data Fellas, with one of my buddies, Xavier Taudoir. I'm based in Belgium so far. I'm creating another one in the US, by the way, now. And my name is Andy Petrella. My social account on Twitter is Nutsap. And let's get started. So Datafella, just a quick note about it. So that's my company. So what we try to do is to get your data to work. So principally, we have a product which is ADST, short name for Agile Data Science Toolkit. And the idea behind is to drive the overall process from the data towards production using services. And the idea is to turn IT and data science departments into a single one. And I will try to explain why we want to do that. So as I said, I'm the monkey. I did math, principally in studies, geospatial. This is where I worked for 10 years. Distributed computing, because a lot of data have to be processed in geospatial, and that drive me to use distributed computing a lot. For instance, I use Spark for 4 years actually right now. I created the Spark notebook, which is a notebook dedicated to Spark so far, and especially for Scala. And I will try to explain as well why Scala so far. Yeah, okay, so in math, I did mainly graph theories and machine learning. Right, so the lineup for today, I try to be brief on that. This course on data science, just a few words about it. Why we should move away from business intelligence in EDL, or at least, how to say, make them evolving in the right manner. To also try to explain why you shouldn't create a data science team, about extending your current team with data scientists. Then finally, JVM, more or less at the end. So we'll talk about why the JVM, why distributed, and functional. And finally, a bit about the agility. So what is necessary in the current ecosystem in order to be agile in data science using JVM, distributed computing, and functional programming. Right, so data science. So as I said, so the slides, it's more just for me to keep my track. So the problem is to define data science, right? So it's pretty hard to define data science like it's hard to define computing science, right? So I would prefer to talk about why data science instead, right? So if we take the computing science, why we should care about computing science in general, right? It's not the only thing that we care about when we do computing science, but we want to be faster, right? So we want to be more predictive, we want to not compute manually, we want to have things automated, and so on and so forth, right? So this is the idea behind computing science initially. why we want to do data science is more, right, so I have a lot of things and I want to understand what's going on. General statement, right? So of course there are a lot of branches from there, but the general idea is to understand what's going on. Why do you want to understand? For many reasons, of course. But the way you want to understand things is in order to act on the system that is surrounding you, right? So you don't want to suffer from what's going on. You want to be able to react on it. You want to understand what's... Okay, so I'm going to start from there, so I will... And I have to speak to the first row as well, but there is nobody over there. Right, so so you want to understand what's going on, so you want to be able to understand what kind of error happened, and you want to predict what you can do, and you want to predict as well what will occur if you do something specific, so which is the kind of thing that you can do with data science when you understand what's going on, right? So when you have kids, he has something in his hands, you can predict what's going on after, right? So for who has kids, he understands me. It's not always accurate, but you want to react, right, on the system. You want to avoid whatever it will do with that. Okay, but matter of fact is that the process is entirely relying on data that you have. Okay, so and the data that you have in your hands is containing some information. Some information. I don't mean that it contains the whole information. It contains some. And you try to extract this information, and from this information you want to create knowledge about it, right? But in order to transform information that comes from data into knowledge, you need another knowledge, which is your knowledge, right? About a domain, specific domain, which means that the knowledge that you will extract from information created out of data is pretty subjective. That's why domain knowledge is always required to create value onto data, using data science. Okay, so I'm telling that because it's upset me a little bit when I see things or products or whatever saying, say, we can extract information from data, whatever the data it is. I don't care. It's not true. It's not true. I mean, we do genetics, we do insurance, we have people in both sectors, so we cannot have the genetics guy to work in insurance and vice versa. It's pretty tough. So that's why data science has to be driven by the business. And getting back to the domain knowledge, during the exploratory phase, which is taking the data, merged it, trying to get a feeling about it, and so on, generally you include a lot of domain knowledge into this process. Why? Because the area is so vast, so you have so many options that you can try, that you have to think about what you want to do and from where you start, right? So based on that, you say, okay, so maybe I can try that and then that, and not take whatever package in R and try every method, okay? So don't do that, like in Coursera, so they say, oh yeah, you improve this package and then you run an algorithm, hey, it's fine, it works. Yeah, true. But it never will work like that in real environments. So the idea is that the data scientist has to have a good knowledge of the system, and also he has to have a lot of luck, of course. And luck can be brute force by running a lot of different things. This is why it retries again and again. And this is how you force luck when you do statistics, right? By any chance. No, chance is not anything. Actually, the more you retry, the more you might have, statistically you can succeed at some point. Doesn't mean that you will win something, but at least you can success at some point. And it cannot be random because the area is so vast that you cannot exploit everything. So this feeling, this sense of information and the domain is never part of the process. It's not encoded in the code. It's not part of the documentation generally, where there is some documentation. So this information, which is, okay, how the guy from the data that he collected towards this model, how the guy discovered that, what were which step did it take, has been taken during this process? This information is lost, so it cannot be reused. So if it's true that code can be reproduced, so the reproducibility of the code is certain if you have the right data. However, the overall process cannot be reproduced easily. So that means that it's very in jeopardy. And now it's even harder. It's harder because big data, you know, this big data thing, is misleading a lot of people because now they think, yeah, now it's easy to do data science, right? It's easy. We have all the data we need. Yeah, first you need to collect them. You need to be able to measure them. And afterwards, you have so many data that you're lost. However, it's true that there are technologies that can help you, that make things easier to compute. That doesn't mean that it's easier to understand. It's the difference between understanding and computing. Right? So now we have this big data that I try to call only distributed computing because big data, I mean, I did geospatial for 10 years. I had big data for long, and most of us generally can say that. So we have terabytes for long, and then what's the big deal? No, the idea now is that with distributed computing, we can do more than we could before, and I will get back to that later. So the problem is that the business is different now. When we thought about data science before, it's not the same right now. When we thought about what was the output, the outcome of a data science product before, let's say 5 years ago, is not the same right now. So let's have a few words about BI and ETL. So business intelligence, when we think about BI in general, we think about reporting, right, and data mining. Yeah, now it includes a lot of things because data science get popular, and then they included a lot of things in business intelligence right now. But initially, that's how we thought about business intelligence. It means that, long story short, as I said, it's about dimension reduction, right? So you want to reduce the data that you have, you want to merge it, and so on, and at some point you want to report it somehow on a PDF or a dashboard. That means that you are data mining, so the word is there, so you are mining the data. So you're not trying to understand what's going on in the data. You don't try to learn so much. You try to mine it, you're trying to explore it, which is really good. I don't have anything against it, but it's not enough. And especially with new kind of data set that we have and new answers that we have to produce. So there is nothing fundamentally wrong with that, but given the ecosystem right now, it's a bit tough to stick with this kind of model. When it comes to ETL, so everybody knows that it's extract, transform, and load. So it's pretty legacy. So and it's the underlying process behind BI, which is mainly taking some data, aggregating, and loading into a database that can be consumed by a BI tool, for instance. It's pretty static. It's not interactive, right? And then it's not very adapted nor for streaming data as well. I mean, the ETL, like it was thought before, right? So there are other kind of extract, transform, load right now, but it's not using the same pattern. If we think about streaming, for instance, the same words are used, but in not the same way. So it's iterative, of course, because every time you want to redo the computation, you have to again extract, transform, load, extract, transform, load. And if you're not happy with the result, you have to do it again and again and again, which is really waterfall oriented. Okay, so this is what we had, and the needs now is to be able to deliver information as fast as we can, right, as accurate as we could as well, so that the business who has the knowledge in order to be able to act on the system can proactively react on its system. Like marketing guys can prepare some mails before a certain event, right? So it will be able to do it if he had the exact information, which is at this date it will be at that level of certainty, be interesting to deliver this kind of content, and then there is no because. It is important to understand that there is no because. We don't know why. We just know that you have to do that, but you don't know why. Okay? Data science is not about Oracle, right? So Oracle is trying to tell you why something will happen. Data science cannot really do that. If people tell you that it's possible, then don't trust them anymore, right? It's not possible. I mean, yeah, there are certain cases when you can do that, but it's very a system under control, right? And even in health, it's pretty hard to do that. It's pretty hard to understand why you have a cancer, even though we have so many data about that. It's painful, but it's the truth. It's the reality. So yeah, it's decided. So let's create a data science team. So we hire a bunch of data scientists that we can find, and we think they are data scientists. And then what? We gather them in a team, and we say, okay, so now we answer questions, you respond to us. You answer questions, you respond to us. Okay? And then we can do some things, but we cannot really report to you what we have done because there is no process in place to do that. So it's like, just monkeys. Put them in a cage, and then you give them puzzles, and you try to have the right result in the end that you cannot check easily. Okay, but yeah, they're not really monkeys. But let's imagine they are, right? But they're cool, okay? So now they're pretty cool. Because they are smart. They can do a lot of things. They can understand a lot of things. They can create a lot of things, right? But that doesn't work. That won't work anyways. Because of their efficiency. I don't mean that they are not clever enough. Far from there. They're probably very clever. The thing is that they are not in the right position to be able to work efficiently. They will, for instance, rely a lot on the data science team, of the IT team to deliver the right data. Again, this is not a problem about the data team at all, right, or the IT team at all. It's just a matter of interactions. So generally what they will want to do is that, okay, so we are the data science team. We are your client, your customer, you IT team, so please deliver the right data at the right moment. The IT guys doesn't work this way, of course, we know that, okay? So the problem will be most on the tooling side. So rather than having this team asking for stuff, so we're trying to have the tool aligned in order to have information fluently going from one side to the other. But data science guys are coming mainly from different areas than we are coming from, and it's going to be pretty tough. I will get back to that as well a bit later. However, since they are the data science team, they should be abstracted from a lot of things, and they will be able to keep their habits, which will go against productivity. And this is what comes after. So, but the thing is, the real point is that they will try to focus on the business, and then we say, oh yes, I'm doing something for the business, so I don't care about the tools. I don't care about the infrastructure. I just want to do something for the business. The IT team on this side is a bit more general. They have to do a lot of things for different topics, right? And they will work in a more transversal manner, right? So if a data scientist is able or allowed to create a new model, and it will have to, a new model for each case in the business cases, for each business case, yeah? I mean, the IT team won't be allowed to do that. They won't create a new architecture, a new infrastructure, a new model, whatever, for each case they have to support, right? So what they will want to do is that to abstract everything and being able to, from using one architecture to serve as many use cases as possible. So that means that the data scientists will want IT team to deliver portion of the data when they ask, because the tool in place is not dedicated for their use case. But the IT team don't have time. They will say, okay, so we have all the things to work on, and and you can even explain exactly what you want to do with the data. It's very interesting. So data scientist asks for some data. He don't know which ones. He just asks for data. And then when you ask, yeah, but what will you do with the data? He says, I don't know. Of course he doesn't know. It's hard to predict what it will do with the data. It doesn't even know what, what data it will have. So it's pretty tough. The interaction is very intense, let's say. So yeah, as a general statement, let's say that most of the data scientists of today are coming from academic or similar, labs, whatever. Their tooling is generally R, Python, Julia. But I mean, if they want to stick with that because they say, I want to just deliver the right answer to the business, then it's dramatic for the IT team because they don't know how to deploy these things. I mean, yeah, I need to create a web service on top of your R script. It's going to be pretty hard. So that means that the IT team that has a lot of things to do will have to take the script from the guy and translate it in something that can be deployed on the current environment. If you think about enterprise, it's going to be most probably JVM, C# or whatever, .NET, all right? So the guy will have to take this, transform it, transpose it into something that can be run. They can put some wrappers on top of the scripts, but then it's going to be very inefficient. That means that during this translation, there is a lot of information which is lost, and it's freaking error prone, right? And I'm not done yet. So the thing is that if the data is available, right? Right now, okay, the data is available. We have our smartphones. There is Twitter, Instagram, whatever data comes into the stream, so we can consume them more or less for free. Actually, the data scientist should play with this fact. So it should take into account that it will have to be able to deal with a lot of data. That means if they have to take as input a lot of data, might it be big data set or fast data set, there is a high chance that the result of his model will be also a big data set or a fast data set. So how could you stick this big data or fast data set into a report in a PDF or a simple HTML page? One single page or one dashboard, whatever you call it, right? It's pretty tough. And it goes against reusability. Okay, so if you think that a data science product is delivering a PDF or a dashboard, then the whole model, the whole process is dedicated to that. So you cannot reuse the information and the knowledge that has been created during the process for other purposes because you didn't expose them, right? So what you want to do is most probably trying to create services on top of the results. And then maybe you can connect a tool that can render beautiful dashboards or render beautiful PDF. But then this has to be done by the business who has the knowledge. You say, okay, so we have this bunch of services. I can take my beautiful Tableau, for who knows it, and then I can, aggregate them and plot several things, and then I will have information. This is in the case you want to have a plot or whatever, but generally what they want to do is to have events. They want to be notified about something. They just don't want to look at plots like this the whole day with a line. You don't know how it appeared, this line, with the result. And then it's time to do something. From where came this line, you don't know. Most probably statistics somewhere. And then what can he do? We don't know. I mean, you cannot know that. And most probably he won't be in front of his computer at that time. We're drinking some coffee or whatever, and then the result is passed, and then the action wasn't taken. So that means that the results have to be reactive, adaptive. Like I said, pushing information, the right information, not just the plot, but say, okay, now the event of upstepping the result as occurs, so you may do that, and then that, right? So sending the right information instead of sending the data, let's say. So if you want to do that, so if you want your data science team to produce results which are adaptive, reactive, and so forth, then you probably have to ask them to do it. That means that they have to learn D3, WebSockets, Android, Swift, whatever, in order to do that, because you cannot really pass the right message to the IT team, which has a lot of things to do. besides this specific use case. So my point of view, uh, as an entrepreneur, is that I won't spend that money for those guys to learn D3. Even if it's a good library, I like it, but I won't spend that money there. I will prefer them to, train some LSTM algorithm, random forest, or whatever probabilistic probabilistic programs, but not taking this time to learn that, right? Because I want to have these teams, IT team and data science team, to team up. Why? Because this knowledge, when I talk about D3 and all these technologies there, is already pretty well known by the IT team, right? So if you want to assign these responsibilities to the data science team, then you might spend time and money on things that you don't want, so you might lose some opportunities market-wise. Then when it's better to have the team collaborating efficiently. So, and why the IT team is already mastering these technologies is because they are facing this kind of needs for long. They have to produce this kind of services of this kind of beautiful interfaces to customers/consumers. So, if you think that you can take the data science team, the IT team, every 2 weeks all together, thinking about what they can do in order to be more efficient, right? What are the different tooling, what are the different contract abstractions whatsoever, and then after the meeting, they go on their own side and work on their stuff, nothing really happened, right? So we all, we all participated to this kind of meetings, right? So we take 2 teams and then, never really happens. So sometimes you drink beers at the end, you get drunk, and then which is generally the happiest way to end this kind of meeting, generally. So anyways, so this never really works. Actually, they have to work as a real team every day. So when I say team, they have to have the same goals. They have to have the same KPIs, right? Because otherwise they will constantly fight one against the other because they have some needs, they have some rules, and they are not coping. So the only way to do that is to hire people, data scientists, and put them right in the IT team. So don't create a dedicated team, and because they might behave like diva, and it's pretty human, by the way. So if they have one single role and goal to accomplish, then they will have to work together. It might explode, right? But they will have to work, in a professional manner in order to target the single goals that they have been assigned for. So of course, you will have to do a lot of choices and compromises on both sides, of course, right? But at least those choices and compromises will be driven by the business, because still the business is included into the assignment of the tasks, right? That means that the overall team, data scientists, IT engineers, become altogether a engineering team. They have to set up the final work environment in order to work efficiently. So the word is a very efficiency. And we will try to be able to have data scientists, producing producing exactly what is needed to put the model or his work in production. So you have to think about it primarily. Otherwise, what could happen? This is what can happen. You can have a data scientist working on the data, asking for the data. It takes weeks. He has the data, models it. It takes weeks. He has the model, and then you cannot deploy it. And the business says, "What? You have it, you can predict, but I cannot use it?" So yeah, we can, but we have to translate, then we have to deploy on the Hadoop cluster, then we have to wait because we're not sure if the accuracy will be the same, because the models are not the same, the implementation is not the same, and blah, 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 blah. And then you get your business upset. It's never really good. So there must be a way to help data scientists to be able to craft exactly what's necessary in order to put their work into production. And they have to agree on that. They have to be how to say, convinced that they have to make some compromises in order to achieve that. And of course, the IT guys as well. However, we might define what is a production environment. So what is exactly a production environment? So this is where the JVM stands for me. What a JVM? So if we get back to data science, it exists for ages, right? But there is a lot of buzz and blah, blah. And now the data science is expecting to run in production, like I say. Let's say in a cluster that is consumed by clients. That is, it has a lot of constraints: efficiency, accuracy, high availability, resiliency, right? All these constraints that have to be solved by the system that will run the models, right? And this is not coming from nowhere, of course. Big data is the culprit. So big data, with all this fancy computing framework, is now able to manage all the data, and it runs in production already, but it's not that smart so far. It just logs. It just consumes data, put it somewhere, but it's not able to be very smart about that. We come to it, but it's not there yet. However, since big data is there for, well, how many? 7 years maybe, at least in Europe, we had a lot of companies that are getting their data, logging, storing, replicating, maybe cleaning. It never really happened, but maybe they cleaned it. Because the data is a new oil, right? So they had done their homeworks. They have the data, and now they say, we have 2 petabytes of data. There must be a way to do something with that, right? Yeah, of course. And there are other companies that are trying to do both at the same time. So yeah, data science is the big buzz. We want to do data science. We don't have data. Okay, rewind, the start of my talk. We don't have information if we don't have data. So these guys are already screwed, right? So we have to first evangelize that they have first to have data, otherwise the process won't be very accurate. But anyways, they want to do it right now. And they want to be able to use it. They just don't want to have labs in their companies. Labs is not good. They want to have teams. Okay? Okay, so we have the data. We want to process it. Let's run some Python scripts, some R scripts, some Julia script on the petabytes of data, or the stream of data. I tried that. I tried that every 2 years, actually. It never really worked, for a lot of different reasons. But I'm not going to talk about technologies here. If I talk about JVM, if I introduce a JVM, at that point, it's not about technologies, it's not about why it's good, but actually it's more a legacy thing. Actually, this kind of environment with these constraints are solved by the IT guys for years, using the JVM, .NET platform, and so forth, right? So they are there for years. They solved a lot of problems regarding this high availability and so forth, right? So they are able to run things efficiently in production. They are able to deal with a lot of clients in there. And this is what we want to do in data science right now. Exactly that. And by chance, we are pretty lucky, right? Because these big data theories coming from Google, Yahoo, Twitter, Facebook, and so forth, right? They created these distributed computing frameworks and these theories. If we take Google, they are most probably the guys who created big data and distributed data science with GFS, with MapReduce, with Pregel, with Blog, with different papers they produced. But why did they create these technologies? Is because they needed to run data science programs, right? So actually, they are data-oriented companies. That means that they face the problem that I've just introduced right now 10 years ago. I say, okay, so we need to have the right environment for those guys to work, so let's create some paper, release them, and then we work on the data based on that. What we had to do as the open source community is to take this paper, implement them. As the open source community, with certain vision. We wanted to have that in production as well. At that time, we took the JVM to do that, and not Python, and not R or whatever, because we were targeting data. We were targeting environment that can run production code, right? So we took JVM for that. So Hadoop was implemented in JVM for that, right? For instance. And the list goes on now. You have Cassandra, you have Kafka, you have all these tools which were based initially on the JVM. So, yeah, so open source pre-production, yeah, JVM was a pretty good choice with the different languages on top of it. We have Java, Scala, and Clojure for the three most, I would say, spread across the different distributed toolkit that we have right now. Of course, we could, as I said, we could have taken different languages like Python, Ruby, R, but the problem is that the last 20 years, so Java had 20 years last year, right? We used Java to run production environments. So we work on the JVM in order to make it robust, right? We didn't do that for Python. I didn't mean that Python is not able to do that. It's just that we didn't do it on Python. We didn't do this work, right? So I worked with, different departments. I worked with NASA. I worked with different departments like that, and they had to run Java in production with all the security constraints, with all the availability problems they had to face, right? So the guys from Oracle and Sun before that had to work on the JVM to make it robust, right? So I never heard about Python at that time. I used Python because I did some work on that, right? But I didn't even try to say Python there at that time. Yeah, we talk about defense department, right? So you have to be very careful about what you say, right? But yeah, so strong of this long experience, we ended up with Hadoop, for instance, and HDFS 7 years ago, because it was a good choice. So Hadoop, for instance, has suffered a lot from its youth. It was one of the first distributed computing generally available in the open source community. And I don't talk about HPC or whatever, right? HPC is very interesting, very funny, but very dedicated to labs and research center as well, right? So it's very tough to run production code on that, unless you are very good at Perl, right? But I am talking about distributed computing technology that run in a more general environment. So it took a certain years before the community also understood that actually MapReduce is a function-oriented concept. MapReduce are just two functions, right? So it took a little bit of time to understand as well that distributed computing is just one thing. It's just sending function to partial data set. So you send function to the partial data set. Why? Because you cannot gather the data set locally to run your function onto it. So you have to send functions. So that means that functional programming languages like Clojure and Scala was one of the most important choices for the new technologies like this, like Kafka, Scala, Spark, Scala, Flink, Scala, Storm, Clojure, right, for the four top most important one. There are counter-example, like Cassandra is Java, okay? So, but it explains why these technologies were using Scala or Clojure, whatever. But also it explains why Java included functions, Lambda functions into the language, right? Why now and not before? Why did they accept it now? Because now we can serialize function and we can send them on the cluster, right? And we can write them in a prettier manner, right? And not a new implementation interface, I don't know what, okay, that we used to do before that. And I'm not talking about functional programming concepts like map or whatever. I'm just talking about functions, right? Just sending functions to the cluster. And then after all the paradigm is unfold on the language to have these different high-level functions or whatever, right? But the very important point is that now we are able to write functions and send them on the cluster. That's why functional programming languages had this raise these last years. 3 years at least. So yeah, I focused a lot on distributed computing frameworks, but also I told you that now creating a report or creating a dashboard, one single dashboard for your output is not good, right? So you have to think about being able to reuse what you've done, right? In order to do that, it's better to have a layer in between, which is probably creating a service, right? That will render all the data that you have created, because I recall that big data, fast data, model, big data, fast data, right? So you have to have a service that is able to render that efficiently. And also being able to take it into another pipeline, right? And also something which is not mentioned here is that in between the process, you have a lot of intermediate steps that might be worth exposing as well. So yeah, general statement. So services is also something that you have to include into your process. That means that JVM is also very good for that. I mean, Java is used in the web as since like what, 2005 or something, even before. The first time I worked with Java for web, it was 98 or something, I guess. So it has a lot of experience, and it's a good fit as well to do that in order to be able to scale it and so on and so forth. And it's multi-threaded. So, anyways, a few words about agility now. So I have 3 minutes and a half. That's fine. So where we are now, data science focuses on business. It has to be responsive and adaptive, right? So we need to be able to provide enough tools in order to do that in this way. So the tooling, the interactive setups, being able to deploy the code directly in production. These production environments are mainly on the JVM or .NET, but different statement. Yeah, so we have to expose everything in a service. Yes, the problem is that, okay, fine, but now how? What do I need to include into my process in order to be able to do that? Okay, so if we take an example, this is how you would do without that in your hands. So you would have a team of 3 to 5 people. You have 3 data scientists. They have a single thing to do, is that to predict churn, right? The classical one. They are working on their own models, right? And what they do, they find the relevant data that can take weeks because nothing is very well structured. Then they do their recommendation. They productize. Somebody will have to productize the model. Then somebody else will have to deploy the model. So we have already spent months here. But damn it, it doesn't work. Not enough accuracy. A lot of cases are failing on that one. So let's retry other models. Okay, another month. Not good enough. Maybe some ensembling now. So we'll take all the other models, we'll start ensemble, and then we'll see what is the outcome on the real data, because those guys had to sample the data. So they don't know exactly how it will behave on the real cluster, because they don't have the full variability of the data, because this is all about that, finally, the variability of the data. If you take a sample, you sample the variability as well. And then at the end, after 3 to 4 months, then you can finally integrate with the business. And that can take long as well, because maybe you produce some JSON, but the JSON has no types, no schemes, or whatever, so you will have to fight with Node.js stuff or whatever in order to have it integrated efficiently. And finally, they're not happy. This is not what I wanted. Come on, let's do it again. So that means that there are a lot of friction between the people, because they are very overstressed about the outcome, about the result they have to produce. So there are many steps where there are frictions, and this is where we have to reduce these frictions. Also, there are a lot of information which is lost in the translation. So I told you, so the guy is taking the data, he doesn't know which one it is, so he has to process it, then he creates a model, he has to find different ways to do it, and then he creates, somebody has to create a service, and blah, 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 blah. And finally, you cannot really easily go back because information is lost. So this is why, in order to be able to do that, again, the idea is to have something which is leading the whole process, which is the code itself. So if you know the concept of notebooks, the notebooks is pretty interesting, is that is a mix of Javadoc with Java code. In the case of Spark Notebook, it's a mix of Scaladoc and Scala code. So you have markup, you have code, and then what you can do with that is that you can generate everything you like. You can generate the jobs, you can generate the services, you can generate the documentation, you can catalog everything, right? And based on that, if you do your homework, you can extract information from your own system in order to exploit it into your business. Right, so it's a few words, so I knew that I will be, I still have 5 minutes, or it's done now? So, okay, so wrapping up, so don't fight, collaborate is the main topic. For the rest, I will push my slides. Thanks, by the way. If you do have questions, we don't have time, but I will stick around there. And I recommend you to come to different talks. I will give talk at Strata and Open Summit and so on and so forth, so check this out.